344 to 354. There are more photos and diagrams in the first textbook, but roughly the same amount of script, the same amount of material. I've been asked by 2 or 3 of you to let you know what's on the exam. Remember, the exam is next week, Tuesday. It includes all of the material that was covered in quiz 3 and quiz 4, plus what we covered today and on Thursday. And again, much like the first exam, you're going to see a lot of material that you haven't been quizzed on. Focus on that first, and then go back over a material that you had been quizzed on. Odds are you will have about 35% in both quiz, covering quiz 1 and 2, or 3 and 4, and about 30% from today's lecture as well as next Tuesday's lecture. So I'm trying to break it up into even divisions, but I just don't have enough time. Okay, one of the aspects of climate and biogeography that we haven't covered are the soils of planet Earth. Now, your author gets carried away, both authors get carried away on soils. You would swear that he's teaching a soils course for ag majors, but we're not going to go there. We're going to look at soils in a general sense, very general sense. I'll give you the highlights of the uniquenesses of soil, the significance of soil, and why we want to spend at least one lecture plus on this resource. Obviously, soils support plant life, obviously. Without soils, we have no plants. Without plants, we have literally no life on planet Earth. So soils are more than just the dirt on your feet. Soils are a complex arrangement of organic and inorganic, water, air, and so on. So we'll cover those each individually in just a bit. So when we look at soil, we realize that we're looking at a very complex arrangement of things in nature. And basically, if we look at the composition of soil, then we're going to look at basically how soils form, and finally then look at what is referred to as the soil profile. So we have three interrelated components. So the first thing we're going to look at is basically general properties of soil. General properties of soil. The first and probably primary property are the inorganic substances. And what we mean by inorganic substances, it's the sediment that makes up the bulk of the soil composition, whether it be sand or gravel or clay or silt or whatever. It's sediment. It's inorganic. It comes from the material that we find on the surface of the earth. This sets the tone for the soil. We'll add to this organic matter. All organic matter starts off first as litter. And we don't mean that stuff you throw out your car window. Basically, litter is plant life that hasn't undergone any decomposition. The leaves that you are raking up now would be plant litter. The branches that fall during the snowstorm in the northeast, this is plant litter. So it's undecomposed materials that are introduced into the soil. These materials do not become embedded in the soil as litter, but they undergo a decomposition process, and that material is referred to as humus. Humus is decomposed organic matter that contributes to soil characteristics. We'll look at the significance of humus in just a bit, but all I want to do here is look at the general properties of soil, and we'll get into more detail in a little bit. Other components that we would look at in soils is the amount of water the soils retain. And water that is retained is generally retained as capillary water. Capillary water means that it adheres to particles within the soil. You don't see the water here as a floating mass, but water that is adhering to organic materials, mineral matter, things of that nature. When you pick up soil particles and you pack it together, that's because of the water in it. You can't extract that water. You can't squeeze it out. The plants can extract most of it, not all of it. But literally, this is referred to as capillary water, and capillary water is what supports plant life. Without capillary water, plants wilt. And we found this year in the Midwest, capillary water supply was diminished because of a dry summer and plants wilted throughout the Midwest. Your garden, when your flowers began to wilt, and capillary water is not adequate for plant survival. So capillary water. So it's not in the fluid sense of the water's floating all over the place. It's literally tied onto individual grains of sand, clay, whatever. And of course, every healthy soil has adequate air. If it doesn't have air, the soil is said to be saturated. Saturated soils are detrimental to plant life, obviously. So if you don't have adequate air, the soil is said to be saturated, and saturated soils are soils that are not extremely productive. Swampy soils, for instance, would be a good example of saturated soils. Okay, so those are general properties of soils. General properties. Now, let's look at the factors which determine soil type. Key factor, number one factor, all the others are secondary. Parent material. Parent material is, again, the inorganic substances that make up the soils. Is it material that is transported there? Is it material that breaks down in a given area? The parent material can be bedrock, it can be delta materials, it can be a wide variety of things. Parent materials come about by two ways. First way parent material is developed is the breakdown of the bedrock. The bedrock is a predominant rock type in the area. If we were to say the bedrock of this part of Marathon County, you would say granite. So soils would develop on that bedrock. The bedrock breaks down by various processes, and we end up with something called regolith. And regolith is simply broken up bedrock. You take big masses and produce small masses. And that small piece of small sediment is regolith. Additional breakdown of regolith produces sediments. Sentiments are smaller fragments.